All right, so this is the last session of the day. Many thanks to Brady for taking us through all the others, and now we've got Damien here to answer the tough questions. So Damien is co-inventor of SignalR.
That's right.
SignalR PM.
Yes.
And I've asked for some tough questions, so hopefully we'll get them. Also, you've got some more demos.
Well, I hoped I'd sort of just protect myself with a couple of demos first before the barrage of hard questions comes through. So.
Can I start with a few? Just
sure. Why? Let's get the ball rolling. And
okay. So some frequent questions are: what kind of servers do you support?
Okay.
You know, is a Windows Server 28R2? Mm-hmm. I mean, where do we work?
So we have that documented. So if you go up to the look at my screen for a moment, go up to the ASP.NET/SignalR site, which I think you pointed out a couple times today. Mm-hmm. And we drop down the left here, and I think it's under Getting Started and under Supported Platforms. So all the details are here. So as it says, Windows Server 2008 R2 and above. Then there's a couple of caveats depending on what transports you want to support. And so you can see here it says, as long as the site's framework version is set to 4.5 and WebSockets is enabled, you can get WebSocket support in Azure websites. And it also says up here that if you want to use WebSockets, you need to be using Windows Server 2012 or Windows 8.
Okay.
So we support lower level servers when running on IIS, but you won't get WebSockets.
Great.
We also have self-host support, and there's some caveats again on there on what you get on what platforms, and so that's all detailed in this document.
Awesome. Okay, we had a question on Service Bus and what the difference is in the implementation between on-premises Service Bus versus Azure Service Bus.
In terms of SignalR's scale-out backplane for Service Bus, it's no different at all. We have a single Service Bus plugin for SignalR, which works equally well on Windows Azure Service Bus or Azure Service Bus and on Service Bus for Windows or Windows Service Bus or whatever it is, the on-prem version. It's the same package, and it works just as well.
Okay, one question, and then I'll let you get to your demos.
Okay.
And we'll keep the questions coming. That's what this is all about. But we've had a lot of questions during the day. What's the performance? What kind of numbers can I expect? How much does it scale?
Yes. Is the answer to that. Yes.
Next question.
I mean, so as with any, and I'm not even kidding, right? I mean, that is the standard answer when it comes to like how well does something scale when you talk about webs. Like we don't have published scale figures for ASP.NET. You can't go anywhere and say, how does ASP.NET scale? Because it all depends on what you're doing. Now, I can give you some reference points based on our own load testing, but you really have to appreciate that adding real time to your web application changes some aspects of how your application scales fundamentally. Like some parts of how your app uses the resources that are available to it on the server will change when you add real time because it's a different type of connection that the browser is making. But to give you some numbers and some checkpoints, and people like to hear these things,
right.
We have a common load test scenario that we run, which uses, I think it's a 10 gigabyte server, so it's a VM, it's not even like a dedicated server, it's a VM that runs on a workstation in the desk next to me, and it has 10 gig of RAM in that VM. And it's like a quad-core workstation CPU, it's a Xeon something or other, right? And with using about 6 other machines just to generate load, which gives you an indication of how many connections we can get, we can connect about 150,000 connections to that server until it runs out of memory. Now, those connections aren't doing anything other than the normal background idle messages. So SignalR sends keep alives between server and client. And so there is data going between them, a very small amount and only once every 15 seconds or so. But the application isn't sending any messages. The clients aren't sending anything to the server as a result of app code or vice versa. If you start sending messages over the connections, which most people are apt to do, then obviously all that changes. It all depends on what you do. And at that point, I like to point people to my other video. So if we go back to my screen for a moment, on this same website, if you click up here underneath, where are we? Learn Signal, I go to videos here. And there's a bunch of talks I've given here previously about SignalR and other people as well. And one of them, if we scroll down, there's 2 that people should really watch. The first one, if we go all the way down here to Scaling the Real-Time Web with SignalR. This is a talk I did at Build a couple of years ago, and it talks explicitly and specifically about what you need to think about when you talk about how do I scale a SignalR application, okay? And it only touches on what Brady showed, sort of the plug-in scale-out providers, briefly. It actually talks a lot about custom scale-out, some of the considerations you have to think about, what type of load are you generating, depending on what type of your app you're doing, and how they all affect how the resources on your server are used. And then the next one, as you scroll back up, is understanding SignalR performance, which is one I gave with David Fowler at NDC this year, I think. Where we do a live load test demo on stage. So I actually remote desktop back to Redmond from Oslo on stage and into that VM I just talked about, and we do like 100,000 connections on stage. Just to show that it's possible and to show what happens. And then we do slightly fewer connections, tens of thousands, then we start actually sending messages. So we actually make them active connections. Then we look at how the machine behaves when that happens. And then Fowler goes into some of the memory tools in Visual Studio, and we actually take dumps of the process, and then we look at what memory is being used as a result of sending those messages and of those connections being online. So you get a real sense of, well, okay, I have 100,000 connections. What does that mean? Why is the machine using 8 gig of RAM? Where is that being used up? How does it change once I start sending messages to a portion of those connections? How does that affect my memory use? So those two talks I would thoroughly recommend people look at, but you really can't get away from the fact that if you're going to be doing any type of significant scale, you need to really understand your message patterns. Like, are you just doing broadcast? Are you doing peer-to-peer? What type of frequency are you sending? Do you have periods where a server will suddenly get bombarded with lots of new connection requests? All of those affect the scale characteristics differently. Just like any web application has things that affect how it scales. So it's not a question I can just answer with a straight answer.
Okay.
Yeah.
We've got a lot of questions pouring in. How about you go in with some demos?
Okay.
And then I'll kind of pick and choose some out of here.
Okay, so if we go back to my screen, I have two demos here. One is, not that one, this one. One is a demo that I prepared with David to do at NDC London last year, but we never got around to doing. And it was a shame because it's a really popular question we get asked, which is how do I track user presence in SignalR accurately? So we have these events in SignalR. If we go over there at this user presence project here, if I look at my user tracking hub, people will be familiar with these events, the on-connected events and the on-reconnected events and on disconnected. And those events simply represent when this server sees a SignalR connection change its state. Did someone come along? Did they reconnect? Or did they go away? Unfortunately, those events alone are not enough to properly track whether a user associated with the connection is actually online or not. Because of the way networking is, and SignalR is not reliable messaging in any way, state or form, it's built on top of HTTP and TCP, you really need to have some other mechanism to determine whether someone is, quote unquote, online or not. And so this is an example of how you can do that. So let me run this application. So it says, I am not logged in right now. So we just have this application is set up to sort of enable people just to log in with a username via the query string, just so that we have multiple users. So here I am logged in as Damien. Let me start Chrome. We'll have a second browser going. There it is. And I'll log in as a user called Chrome over here. Now, the green box in the browser is there to represent the state of the connection from the browser's point of view. So we have this status box in this app that just says, hey, is the connection currently online? Is it in the reconnecting state? Or has it gone into the disconnecting state? It'll go red. And then we have some code that'll kick in to try and get the connection up and running again. Then on the server, we have some code that tracks whether users are online based on the events that SignalR raises, but also on time. So this is where it really comes down to. When you're doing user presence and networks are involved, you need some type of state that is not your server. Because the server goes up and down. That's part of connections going up and down, is that the server might recycle. The client sees that it's going into the reconnected state, but your server now is gone. So if you want to have some state about who was online, it needs to be not in your server.
Right, and we saw that example the first session of the day. We did hit counter, and partway through, Brady switched it to turn on WebSockets, and when we did, hit counter dropped to 0.
Right, and so this example shows how to do that. We have a SQL server over here on the left, and you'll note I have two tables. I have a DBO.connections, which I'll open up, and we have DBO.users. And so this is just a sample schema. The Jabber application, I don't know if you talked about that today, which is a SignalR chat application. Yep. It uses this mechanism. So this demo is actually built using the code from Jabber, and we basically simplified it right down to its core essence, which is how do I do user presence. So I have a table that represents all the connections, SignalR connections that my application is tracking, and I have another table which is just my standard user table. Okay, this would probably already exist in your application. The connections table is most likely the new one. First thing to note is it is separate from the users table because, of course, users can have more than one connection be active at any one point in time. In this case, I have 2 separate users and 2 separate connections. Okay, so the application is tracking that. I can open up these 2 browsers. Let's see what happens when I go ahead and close one of my browsers. So Chrome is now gone. If I hit refresh, you'll note that that record disappeared immediately. Now, the reason that record disappeared immediately is because when the browser closes, the SignalR client sends a request to the server to say the user has closed the browser, effectively. It's also the same if you call the connection.stop method in the client. We send a request to the server which tells SignalR the client is going away, like proactively. And that's why this demo was able to delete that connection row instantly, because it just knew straight away because it actually had a request saying someone, called stop.
Right.
That's not always how it works, right? So if I start this again, and let's go to this again and look at the other scenario, where we don't close the browser in a nice way. So let's log in as Chrome, come back and refresh. So now I have the row here representing Chrome again. I have a different connection ID. But this time, rather than closing Chrome as a nice civilized person would do, let me go into Task Manager and end that task. So now if I hit refresh, it makes a complete liar of me by deleting it straight away. Now, of course, these things it actually detects that it didn't shut down quickly. Let me try it with IE. It may be that Chrome is trying to be really clever here, and when we shut it down, even from there, it's having a chance to fire the window close event. So let me try it with IE, and if that doesn't work, I'm going to go to the command line and write kill. Yeah. And see if I can get it to kill that way. So let's see if I can pick the right IE instance. Looks like it's that one. And I will end that task. So that looked pretty graceful to me, and it actually did go away. So let me try a command line.
Or can you go to process? Well, a command line kill will definitely do it.
Okay, so let's try that. Let's go to here. And I will... Now, what I'm trying to do here, right, is represent a client that simply disappeared from the network without it having a chance to tell the server that it was going away, right? That's why I'm going to all this trouble here to do this. So let me do kill, and I need a process ID, so let's come over here. Go to details, we'll find Internet Explorer. And I have so many. Let's do Chrome, even though there's 4 of those. Now I get to figure out which one is the correct Chrome instance. Let's have a look. Anyone know how to quickly figure out which one is the right? I can just kill them all, I guess, can't I?
Well, you can go to the Chrome Task Manager, but I don't know if that gives you the process ID.
That's a good idea, though. Let's do that. So that's in here, right?
Yeah, it's a little hard to find. It's in Tools. Well, that might work.
Nope.
Yeah, okay, go to that drop-down. Tools is right there, yeah.
Oh, there it is. Okay, excellent. All right,
it has process ID over there.
Perfect, 10612. So we're going to try and kill this tab over here. Oh, well, that's this one, 11556.
Okay.
Okay?
11556.
So in theory, over here, I haven't done it yet. I should have 2 records. Yeah. They're both username Chrome both username Damien because I put Damien on the end of this one. Okay. So let's do this, see if this works. Oops. What was it?
11556.
Okay, that disappeared. And now we have success.
Finally. Okay, wow, so that was hard.
I was able to kill the process in such a way that it had no chance.
Crash on me all the time.
I know.
Finally, we can't get
in a demo. That's how hard it is to actually replicate this. So what have we simulated here? We've simulated a client driving into a tunnel, for example, and losing network connectivity, or having a hard browser crash, or their machine crashes, or something like that.
Right.
They didn't get a chance to tell the server that they're going offline.
Yeah.
Another scenario will be if you're running the browser and then you close the screen of your laptop and it goes to sleep, it won't fire the appropriate events in the browser that we use to tell the server that it's going offline. So you'll see this. So if we go back to my screen now, what will happen is after a period of time, that record will go away, and it did. So after a while, the record went away. Why did that happen? Well, if we go to startup.cs, how did we make that happen? We have this thing here. We look up something from the Global Host Dependency Resolver, which is the iTransport heartbeat. Now, this is the class inside SignalR that tracks connections in the background of your application. It still runs in your application. It's just always running on a background thread. All right. So even if there are no requests, this thing is still checking for active connections.
Wow.
I am going to take that heartbeat and I'm going to pass it into this custom class that's part of this demo. It's not part of SignalR, it's part of the demo. Pass that into the presence monitor and called start monitoring. So let's have a look at what this class does. And again, all this code that I'm about to show is available up on GitHub under my GitHub account, and I'll show the URL at the end.
Yep.
And so this is a fairly simple class. What it does is it sets up a timer, and that timer ticks on some interval. It's not really important when it is. It all depends on how long you want to wait in your application before you consider a connection as truly, truly gone or a user is truly, truly disconnected. Okay? Yep. So we have our own thresholds inside SignalR, which we use to determine when the disconnected event gets raised. And you can mimic those in here if you want to sort of get symmetry between when the events get raised and when your application considers someone gone. So when start monitoring is called, we create the timer if it doesn't already exist. And the check method is what gets called on each tick of that timer. Okay, so let's just pretend it's ticking every 15 seconds. What it does is it goes through and calls get connections on that heartbeat. Now the heartbeat, if I scroll back up, just to remind people, is this interface here, iTransport heartbeat. This is a thing that comes from the guts of SignalR, is already running in your application, and you can call get connections on that to get its state of what how it sees the world of SignalR. This gives you all the connections that are currently being tracked.
Okay.
There is a flag on each one of those that indicates whether SignalR still considers that connection alive. And if it's not alive, then we just keep going. Okay. If it is alive, then we go through and start updating our state. So this was the database over here. We start updating the database with a timestamp that represents the last time we saw that connection in the inactive state. And then what will happen eventually is that state will get to a point where we haven't seen that connection for a period of time. And it gets over the threshold that we talked about. Okay? When that happens, when the on-disconnected event is raised down here, or is called, I should say, we go ahead and find that connection ID and we delete it. So it's a really simple time, sort of a sliding expiration type thing. So if you're familiar with sliding expiration in cache systems, this is almost identical. If the connection comes online, we update the thing saying, hey, this user is online, and this is the last time we saw them. If they go offline for a period of time, 30 seconds, then we go, oh, well, we haven't seen them for 30 odd seconds now. Let's go ahead and delete that row that represents that they're currently active in the system. Now, in an actual application, what you would usually end up doing, obviously, is you would have a list of users here as well, and each one of those users in your list would have a status icon that represents whether they're online or offline, which would be driven by this database table right here. And that's exactly how presence in Jabber works. So we have a table like this, represents the connections are online, and it gets updated to the clients to say, hey, Damien just went offline because we haven't seen him for 30 seconds, or he closed his browser and proactively told us that he was going offline.
Okay.
So we have these we call those like a graceful disconnect and a disgraceful disconnect. Graceful disconnect is when the client gets a chance to tell us. Disgraceful one is when they bow their head and walk away, they don't tell us. And so we have to just sort of let them go 30 seconds or so later.
Right, okay.
So the other scenario that happens here is that, say everyone's online. So let me hit F5 just to prove that it's here. Let me kill the web server this time. Exit, gone.
Disgraceful. Disgraceful
destruction. And you'll note that both browsers went into that yellow state to say that they're reconnecting.
Okay.
So we're still within SignalR's phases of SignalR is going to try and get this connection back. After about 30 seconds, SignalR will just give up. It says, look, I haven't been able to connect to the server in 30 seconds. And what we'll see is these two boxes will go red. Now, at that point, if you don't write extra code in your application, the connection is dead, right? The client will never try and start it again until you call start in your application.
Okay.
So now they've both gone red. Yeah, I timed that beautifully, didn't I? Now they're both red. So now the application is entering another phase. And that's the phase that we actually coded into this demo. It does not do this by default. So let me go into my index.html. I'll scroll down here. Here's the JavaScript code that is handling the state changed event on the hub connection that's changing those background colors. Okay. Here's the last one. If it goes to disconnected, let's change it to red. The next thing is that when the disconnected event is fired, go ahead and call window.setTimeout. So after a second, just call start again. And start will flip it into that phase of connecting.
Trying to connect.
And then if that fails still, because I haven't started the web server, disconnect will get called again. And
go right back
it'll start again, just starting again. So in theory, if I hit Control F5 now, what we'll see if I go back to the other browsers is that they come online, which they did. So now they're green again, because all I did was start the server. Because I've written that code in the client that even when the server dies, as long as it comes online sometime in the future, the client is consistently trying to call back to the server, and we can see that the connection went green again. So there it is. That's sort of our canonical example of how to do connection status and user presence within an application using some type of persistent state, in this case just a SQL server.
Great.
I was going to point to the code of that so that people can get to it.
And I posted the link in the chat as well.
Oh, excellent. So if you go up to my GitHub repository, that one is under NDC London 2013, and there's under here, user presence is that one.
Great. We've had a ton of questions come in.
Okay.
I can fire a lot of these. You can just boom, boom, boom.
Let's do that now then. Yep.
And then if you want to go to another demo later, we can. Okay.
Perfect.
So Steve Wood has a longish one, but he's using SignalR in a Windows service to a web application, and then down to a client. It's working really well. Hundreds of messages posted every minute. However, he notices memory usage, and this sounds like what you were talking about earlier. Memory usage in IIS goes up and up. Is there any issue with using SignalR that way? And he said the application's just relaying messages now. There's no obvious place for him to look for memory leaks. What's going on?
So SignalR does message buffering. So the reason that how reconnect semantic allows a connection to go offline for a brief period of time and then come back and get the messages it's missed is because we actually store messages in memory. And so if you're sending messages a lot, you're going to start using up memory. Now, we don't do that infinitely. We use a ring buffer structure in memory so that we only ever store a certain number, and then they just start overriding the oldest ones. That number is 1,000 by default.
Okay.
So for every single signal that you will send to, now I don't know if you talked about this today, but signals in SignalR are basically the unique keys that represent a way that you can send a message. So if you send within a hub, you do clients.all. some method name, that's sending to the hub signal, which all connections that are connected to that hub subscribe to. If you did clients.groups.foo, some group name, and then did some method invocation, foo is the signal there because foo is a group on that hub. So the signal is actually a composite. It's a combination of the hub name and the group name in that case. That's a unique signal. So if you send messages to that group, it'll store 1,000 of those messages before it'll start overriding them.
Okay.
So if you're sending, note that I said the number of messages, not the size of messages. So if you're sending large messages and you send a lot of them, you're going to use a lot of memory by default.
Okay.
Now you can tweak that number. If we go back to my screen for a moment, let me see if I can find that setting. Off of global host, we have configuration, and we can see default message buffer size. That is 1,000 by default. You could set that to say 100. And now you'll use 10% of the memory you would otherwise used. But you are giving up that backlog of messages that connections are able to pull from when they come back and say, hey, I was away for 5 seconds, give me everything I missed. The smaller this is, the less messages they'll be able to get.
Great.
Now, currently in SignalR, this is one global setting for all signals. We are talking about in future versions enabling you to set this to a different number for the different types of signals. So you can say this group gets 1,000, but this all users only get 10, and like this hub gets 100, but we don't have that right now. So.
Great. Okay. A related question says, how do I handle large dynamic data set synchronization, specifically how to handle when a client is downloading the set but changes are happening? So the idea is, there's dynamic data and we're maybe just updating little bits of it.
Yeah. That question isn't really a SignalR Connect question at all, and so I'm not even going to attempt to answer that because I am not the right person to ask about client to service or data synchronization strategies. I mean, that's a really hard comp sci problem, and we have technologies that attempt to solve that. And you can try and do that yourself. You can do deltas, and you can do like replays with item potency and all these types of comp sci stuff that I can't answer like in that sort of way. I would suggest that person look into sort of general, how do I do data synchronization between one end and another?
Yeah.
Especially when I'm in the middle of receiving a delta and it fails.
Potentially Breeze.js might help with that. I don't know, but Breeze.js has this kind of client state synchronization thing, and I don't know how well it works with SignalR. But
potentially, yeah.
Okay, here's a really tough question. Where do we get the cool shooter t-shirt that Damien is wearing?
Yeah, unfortunately there was a limited run done on these t-shirts about 2 years ago when we did the shooter demo at Build, and we haven't made any more. Okay. We really should get around to putting it up on some website and just let people buy them.
Yep.
But, yeah.
Okay, Yuri asked, did I get it right that a hub is a singleton if we check timer equals null? I assume we don't create a timer for each user. If yes, can I have few hubs in my app, or it doesn't make sense, and should I have only one hub per app?
Right, so if you're talking about the user presence demo I just gave, which is what I'm
not sure, honestly.
Okay, I think that's what he's saying. It is one timer that's being created here. So if we go back to my screen, the presence monitor class that I showed here, there is a singleton instance of this for the entire application, and you can see that the timer is just an instance timer on top of that, and it just gets created once.
What about just general, like you talked about background processes in SignalR? Is there like a one timer, like heartbeat kind of timer, or are there multiple timers?
In SignalR itself, there is one.
Okay.
So on the server in SignalR, we create, actually this iTransport heartbeat class right here is the one that maintains sort of the SignalR-wide timer that wakes up periodically to do things like check if connections are still active.
Great. Okay, here's a question. Chris asked, any idea what the performance hit is for using backplanes for SQL and Redis?
Incredibly large. So when you use a backplane, the thing to understand, that's what people really have to watch the talk from Build to sort of get all the details in this. When you configure a SignalR backplane, whether it's Redis, SQL Server, or Service Bus, you're telling SignalR to send all messages to the backplane. It's authoritative, right? It's not, let me send the messages to the connections I have on my server and then send it to the backplane so that other servers can get it. It's every message goes to the backplane, and then the server that the message originated from, it won't actually be able to send that message out to clients until it goes through the backplane and comes back, and then it goes out. And so you're limited on total system throughput by the speed at which any given server, web server, can pull messages off the backplane. Because the other aspect of our backplane providers is that all messages go to all web servers. We don't filter the fact that if you have 3 web servers, but a user on one server connected to server 1 tries to send a message to a user on server 3,
it goes to
every web server, even if that user isn't connected to the middle server. That is a limitation of our scale-out architecture, which, as Brady said earlier, means you have to really understand how you use scale-out and how you use SignalR, because you're going to get to a point where our scale-out providers just don't scale. At that point, you have to look at doing custom scale-out mechanisms, and we have a talk, that's the Build talk, that talks about some of those things. So.
Okay. 5 more questions, and then I'll let you do the other cool demo. Okay. So Neil asks, do you have any patterns IT operations should be looking at when monitoring or managing a production application using SignalR in Azure?
Wow, that's an interesting question. Just like any web application, you basically have 3 or 4 resources you have to look at, right? You have CPU, you have memory use, you have network bandwidth. They're really the big 3 things that a web application has to consider. SignalR affects all 3 of those things. Right?
Okay.
Obviously, the 4th one is sort of, you can kind of couple with bandwidth, but it's the number of active ports being used right now on the server. With SignalR, because the connections are persistent, and they stay around for a fairly long time, your ports are going to be active. So if you have a firewall, especially if you have things like a firewall in between the clients and your web server infrastructure, you have to ensure that the firewall is set up in such a way that it can sort of maintain those active connections. We generally recommend that you use HTTPS and SSL when using SignalR, especially for things like WebSockets, because it allows you to tunnel through a lot of HTTP appliances, whether they're reverse proxies or routers or cache systems and things like that, because they tend to go, oh, it's SSL, let me just get out of the way, because you guys are partying on the connection, I really can't see what's going on here. So if you do SignalR over SSL, you generally can avoid a lot of the problems of like the proxy server won't let me do HTTP streaming, for example. But in terms of what the IT people might want to be looking at, as I said before, if you send live messages, we are going to store them in memory for a period of time, so that will affect your memory. The number of connections added to your server will create buffers to send data out over the network socket. That will create memory usage. When you're sending a large number of messages or you're sending complex messages, we have to serialize those messages. And so if you're sending lots of individual messages to different people rather than doing like the mass broadcast scenario, we have to serialize all those messages, and that takes CPU. How much it takes all depends on how complex your graph of the message is, because you can just give us an object, right, a .NET object, and we'll just serialize it using JSON.NET. So you may get CPU overhead there.
That may be a case almost where you'd want to use persistent connection because you're not, and just pass a string message, right?
Yeah, so
some of that.
Yeah, Hubs has a little bit of overhead because we have sort of that envelope that goes around the messages. Persistent connection, we have an extra optimization whereby on the server it still has to get encoded as JSON. Okay, so we don't have binary; it's still JSON ultimately. But if you've already encoded it into JSON UTF-8 bytes, you can give us those bytes directly. You can actually give us an array segment, not even copy the bytes. You can just point to where the bytes are, and we will just go, oh, okay, let me just take let us just create an array segment inside our message store that points to those existing bytes. So we won't copy memory, we won't reserialize, and when the connection that message is intended for comes around and asks for delivery, we'll quite literally just read them directly from where you were and send them over the wire. Now, if you give us an array segment of bytes that aren't JSON encoded, we're going to send them anyway, and then the client will obviously just explode because our client will go, oh, I thought this was JSON, and you'll get this weird sort of experience. But that is available, and there's a demo of that inside this same solution that I'm demoing the user presence from.
Great.
So we showed that.
I'll try and rip through some questions quick. We're close to running it. We got like maximum 15 more minutes. So we have a question. How do you define a session in SignalR? Is it opening a tab, opening a new window, sending a request? Does our data get stored in all of the sessions?
Okay, so if I go back up, look at my screen again. If we go back up to the website, don't you love it when I can answer a question by go read the doc? We have a documentation about connection lifetime. And I just have to find it. I think it's in the Hubs API section, and I think there it is. Understanding and handling connection lifetime events in SignalR. And it talks about the different layers of persistent connection and hub and those type of things. And down here, you can see it has some timeline diagrams that show when a SignalR connection starts and when the various transports might start and stop over the lifetime of that connection, and then where the events are raised from SignalR's API's point of view based on when the transport stop and starts. So this is probably the best answer, is to go and read this section of this document, and it'll tell you. Okay.
Yuri asked a question, how do I know if a call to send message failed on the server side so I can resend the message again? This gets back to that whole, is it durable messaging?
Right.
What can I count on?
I'm not sure whether they mean send from the client or the server. So from the server to the client, you can't. There is no type of reliable messaging exchange that happens between server to client. And because when you say send on the server, that's asynchronous, it actually, the task we give back to you does not represent the delivery of that message, because the message could be going to more than one client. And it could be on a different server. It could be the other side of the world. We don't do tracking of messages all the way over to there and back again for your messages. Now, dirty little secret, we do it for some of our own internal messages. So like group addition, when you call groups.add, the task that comes back from that call does represent the client receiving that command to add that group. Now, when I say client, though, it only represents the fact, the representation of the client on the server, not the actual browser. It represents the thing in memory on the server where the client is currently connected to, receiving that command saying, yes, I have to add this user to the current group. But we don't expose that ACK capability to the API because it's kind of dangerous. Okay. But from client to server, when you call send, if the send fails, you get an exception.
Okay. Right. One last, hopefully relatively quick one. We'll let you get back to your demo.
Yep.
Gaurav asks, can we use SignalR for audio file communication?
Yes, but don't do it.
Because you'd be like serializing audio in JSON. And
it's just not the right mechanism for it. Again, sending stuff over HTTP, if you just have a set of data that you need to send over HTTP right now, just post it. Like, we know how to do that, right?
Right.
If you want to do fancy stuff like progress, you can still do that using a combination of SignalR and a more sophisticated receive handler on the server. Mm-hmm. So you can use things like the HTML5 file API to read stuff off disk on the client in the browser. Then you could send that to the server in chunks over either a dedicated WebSocket or just using multiple HTTP posts onto a handler that you've written on the server that knows how to say, hey, okay, well, I'm currently receiving chunk 7 of 50 for this file, right? And then parallel to that, you can have a SignalR connection running from the browser that's coordinated via a hub on the server that can tell you that the server is currently processing chunk 7 of 50, so you have that progress going on. So you can kind of do it that way, but you're not actually sending the data over the SignalR connection, you're just using it for real-time update.
Great. Okay, we've still got more questions coming in, but I want to let you get back to your other demo.
Well, let's do the other demo, and then we should have time for some more questions after that. So the last demo is another sort of pivot on the chat application. Now, the idea of this demo in particular is to show how to use the .NET client API for SignalR in such a way to get a more reliable connection and also to give the application that you're using it in sort of status so that the user can see whether the connection is currently up or not. And it's also shared across a Silverlight phone application, a Windows 8.1 application, and a universal app between Windows Store and Windows Phone. So it kind of shares a lot of code, which is kind of cool too. So the server's pretty basic. That's already running. I have the phone application running here. Here's my chat. And I think over here I still have the chat running, or I don't. I don't, because I'm lying. Let me run that. Okay, so pretty typical thing. I have chat here on the left is the browser, and I have chat here on the right, which is the phone app. Now, this is a XAML phone application, and so one of the things that this demo tries to set out to do is to show you how to simplify the problem of handling asynchronous messages arriving in off the SignalR connection, and then getting those into your UI from a background thread, because that's what it is. When we end up calling sort of your hub method in the client, in .NET, it's coming from some random background thread, okay? And so anyone who's ever done a XAML data binding knows that you have to get that call back onto the UI thread before the data binding will work, otherwise you just get data binding errors. And you do that using the dispatcher. And so what we've done in this demo is we've created sort of a reusable version of SignalR's hub API in the client that does that dispatching for you. So let's just sort of show how this works first. Okay, so hello from IE, I can hit send, and that shows up over here on the right. I can say hello from phone. I can touch send here, and it sends, and we can see that's working. You can also note that I have the SignalR log being plumbed into the UI here. So the .NET API for doing in the client for enabling tracing is done via way basically of a text writer. So you just have to give us a text writer. You basically assign it to a property.
And it logs to it.
And then it logs. So what I've done in here, and I'll show you the code for this. Let me go into the Silverlight phone app. And let me find the trace output. Output. Nope, that's not right. Let me do it there's my main, there it is. Data context, and of course I've done all this in the shared code, which is why I can't find it. View model, chat view model. Okay, so I've written this, the .NET part of this client application using a very simple sort of model view model architecture, because it's the easiest way to share the code between all the things, and just to demonstrate how you can kind of do that. And so I have this log messages property, which is an observable collection, because I'm going to be binding to it from XAML. And if we go and have a look at my actual UI, let's look at the Windows Phone example here. Look at my main page. I'll just scroll over, we don't need to see the designer. We can see down here that the log pivot item just has my grid, and it has a list box, which is item sources bound to that log messages property that I just showed you on the view model itself. So that's fairly straightforward. And then there's just a data template, right, to show the item inside. Standard XAML stuff. I'm not the world's best XAML developer, but I've done a little bit of it. So hopefully I'm not making people who do XAML scream and pull their hair out right now. So I have this log messages. So how is that actually populated? Let's go and have a look at that. Looking for symbol and XAML files. So down here, you'll note that I'm populating, I'm adding messages to that log messages collection when things on the connection take place. For example, if an error is thrown in the connection, I'm just adding a message into there so that we can see that. But I'm also redirecting all the trace outputs. I mean, these aren't errors. This is just all the various trace information that SignalR will write out. And I'm showing that in that log messages collection. And I'm doing that by, and I've just got to find that class, this thing, the collection trace writer. So I wrote this collection trace writer, which derives from TraceWriter, which honors the TraceWriter API, but just rather than writing out to any type of file, I just throw the individual messages into this collection. As simple as that. And if we look at the callers on the constructor here, you can see that I'm calling that inside my chat view model and passing in that log messages API, and then I'm assigning that to hubconnection.TraceWriter. So there's a couple of levels of indirection going on there. So let me just summarize that. Hub connection is a standard SignalR hub connection, kind of. We'll talk about that in a minute. TraceWriter is the mechanism that we use in the .NET client to give you trace messages. So I've turned on tracing by saying tracelevels.all on traceLevel, and then I've assigned this collection TraceWriter to the TraceWriter property. So when the hub connection wants to trace something, it's going to call the various methods on collection TraceWriter, such as writeLine, and then I'm going to, inside of there, just end up adding those messages directly to log messages.
Right.
So I'm just sort of like doing the bouncing ball all the way through so that it just binds directly to the API, which is kind of nice. So I'm a big fan of data binding, so I try and create data structures like this to help me do data binding really, really nicely. So the astute watchers will notice that my hub connection isn't a normal hub connection. I actually have this thing called a dispatching hub connection. So this is the custom code that I've written that effectively it's a standard hub connection, but all callbacks will be executed on the dispatcher that you pass in. And that's what the comment above it helpfully tells you.
Right.
So that you don't need to do locking and posting in your view model or in your code behind for your example. It's just handled for you. Yeah. You just deal with the hub connection like you would using the standard .NET API, and it'll just model bind perfectly. So here, for instance, when reconnecting happens, I set a property on my view model called canSend to false. If we go back to my page, we'll note that the send button, it's a enabled property, if I can find it. Oh, it is bound to, its command property is bound to the send message command. If you've used, now I'm introducing so many concepts of people who haven't done XAML, so I'm just going to assume that everyone watching right now has done XAML and knows what I'm talking about. So this button is bound to the command. The buttons inside XAML understand commands, and commands have a concept of being enabled or not. So if the command that it's bound to is currently not enabled, you can't click the button. Okay. And so I don't have to do like enable the button, disable the button, or anything like that, because it's already bound to a command that's encapsulating that for me. So if I look for this send message command, don't do that. Let me look for the send message command. Here it is here. All send message command is, it's a property on my view model, which is why I'm able to bind to it, and it's an instant of delegate command. Now, delegate command is a class that I wrote that implements iCommand that basically executes a delegate. That's the command. You just give it a function to call. That's here, execute, and another delegate that represents whether it can currently be executed. So there's your enabled, disabled, right?
Okay.
And so when that connection goes into the reconnecting state, if I scroll back up here, on reconnect, I'm setting status, a status message, and I'm setting canSend to be false.
Combined to that.
So if I look at where canSend is actually accessed, you can see down here, when I create that send message command that the button is bound to, I'm passing in a delegate that just reads the value of canSend.
Great.
So that command knows if it can run or not. Simple as that. So back here, if I kill the web server now, what we'll see if I go back to chat, currently I can send, right? That works. If I kill the web server, first we'll see the status changes to reconnecting, and I can't send anymore because the command is invalid.
Okay.
If I start the web server, it's now connected and the button works again.
Great.
So that's kind of an overview of the type of things that we're trying to demonstrate in this this sample. So if people want to know more, get the code. There's a little bit of code here to make that work.
Yeah.
But the crux of it is the chat view model, which is where your code goes, isn't having to deal with the sort of the intricate, I have to take background messages from SignalR and post them to the UI, and I have to lock here because I have multiple messages trying to update my message collection at the same time. That's just all handled for you by this dispatching hub connection. Now, if people really like this, we might consider actually adding this API into the .NET client at some point in the future, but for right now, the code is here and people can use it in their application.
Awesome.
Yeah.
Okay, we've got the 2-minute warning. I want to
Awesome.
see how many real quick questions we
Let's
can
do rapid
blast
fire
through
question round
in
right
like
now.
a minute and a half.
Okay.
Okay. Could I do complex filtering for a client lookup, like filtering by age and gender to send message to males between 18 and 25? I think what this is asking, can I add...
The answer is no.
You can't add a person to multiple groups.
You can do that,
but you can't do complex.
You can't do lookup. So you would have to manage that group membership yourself.
Awesome. Okay. Talking about scale out, they're wondering how SharePoint Online works with document collaboration. Do they just have a bazillion servers, or because all these servers don't even know about what's on?
So they're talking about the Word Online and PowerPoint Online currently support collaboration on document. That uses SignalR. They make sure that both or all the people currently working on the same document are on the same server.
Okay.
So they don't just scale out that way.
2 more quick ones. Is Microsoft planning on guaranteeing SignalR message delivery, or is it just impossible due to infrastructure SignalR is built on?
SignalR will never do reliable messaging.
Great. Okay. How would you compare SignalR with Meteor.js? Is this too big for it to answer?
Meteor is a lot larger than SignalR. Meteor is an end-to-end stack that encompasses the server and the client and an app development model. And so Meteor includes a real-time component, which is like SignalR's real-time, but SignalR is more of a building block. Meteor is an end-to-end stack. Now, there was one more question I wanted to answer that Brady wanted me to point out, which was removing the jQuery bindings or the jQuery dependency in our JavaScript client. That is on our backlog. We are looking to do it in the next 6 months.
Great.
Yes.
I need to wrap up in about 20 seconds. I want to remind you, first of all, to take the poll. That's very important. It helps us to continue to keep these things going. If you have questions, if we can cut to my screen, if you want to learn more, asp.net/SignalR is the place, right, to learn about stuff. We also have been pointing you towards this book. This is a great book from MS Press, and I recommend you look at this.
Yep, great book.
We also have Web Wednesdays. This is another in the series, the 4th Wednesday of every month. Thank you all for showing up. Thank you, Damien. Thank you, Brady. Had a lot of fun, learned a lot. I hope you did too.